Hello everyone. In this video, we are going to say about mechanical pressure gauge with types and its applications. So myself, Dinesh Kumar from Hindustan College of Engineering Technology. Okay. So what is meant by pressure gauge? So pressure gauge is nothing but any equipment or instrument that is being used to measure the pressure of and that equipment, particular equipment. Okay. So pressure is basically comes from a fluid that may be a liquid or either may be a fluid. Okay. Either may be a gas. So that is where the mostly the pressure will be liberated from any particular object. In that way, we will measure the pressure by using a pressure gauge. Okay. So where the pressure gauge usually applied? So it is usually applied in industries such as chemical, power plants, manufacturing, and automotive applications. So that is basically apart from IT sectors, pressure gauge is essential for all the other industries. Okay, even when we are going to fill out uh, air tubes of our two-wheeler or four-wheeler vehicle, we are going to fill tires with tube tires with uh, gas. So that particular gas is being supplied from a compressor. So from how the compressor is setting out the pressure, how the compressor is giving the gas is through the pressure gauge. Okay, particular pressure will be set at that from the particular set of pressure, it will be distributed to the tires and tubes. Okay, so how it will improve the equipment is it will improve the process safety and efficiency and equipment protection for any equipments. Okay, any protection for any equipments. So these are all some important things that for why we are using a pressure gauge. Okay, so pressure gauge is usually classified into two types. One is a mechanical pressure gauge, and another is an electronic type, electrical or electronic type pressure gauges. Okay, so why pressure gauge is being importance that we have already discussed. So ensuring equipment operates within the safe design limits. Okay, so and to prevent accidents like pipe bursts, boiler explosions, and pump failures. So we have seen many boiler explosions because the particular boiler cannot withhold such amount of pressure. So if we know how much pressure is inside the boiler now that we can control the pressure by releasing it out. Okay, if the pressure gauge is not working properly, means what will happen? We don't get the correct value, of pressure gauge. So we will use pressure gauges for the particular thing. So and for the quality control and the predictive maintenance and to reduce the downtime. So regular periodic maintenance will be takes place by using a pressure gauges and accurate data collection. So accurate data collection have some reserves, but still we will get some data collection through electronic gauges. Okay. So classification of pressure gauges initially we have seen one is a mechanical type, another one is an electronic types. So mechanical gauge is basically by elastic elements that deform. Okay, but electronic gauges is usually based upon the sensors. Okay, one is a strain gauge, piezoelectric capacitive. So in this PPT, we are not going to see about the electronic gauges. We mostly concentrate on mechanical part. Okay, in the mechanical part, it is being differentiated into three types. So one is a diaphragm, another is a bellow, another is a Bourdon tube. Okay, so diaphragm, bellow, and Bourdon. So first one is a Bourdon tube pressure gauge. So as you see in the GIF, okay, in this GIF material, as you see, the pressure is being applied from the bottom. So what's happening is the pressure is being applied from the bottom, and the spring kind of a thing. It is being elastic. Okay, it is being improved. If the pressure is high, it will improve. So what's happening is it is being attached with the lever system, pulley kind of a lever system. So through this pulley system, we get to know how much amount of pressure is being applied from the bottom. Okay, if the pressure is very less, it will expand very less, and the needle will only show here. Okay, if the pressure is higher, what will happen? It will goes here. So in the similar way, we will get a value by using Bourdon tube pressure gauge. So this is the content for the Bourdon tube pressure gauge. Okay, this is the diaphragm pressure gauge. So from the diaphragm word itself, we can understand that this is kind of an expansion material. So as you see, the pressure is being entry from the bottom. So from the bottom, it is kind of a polymeric material which is able to expand. Okay, which is able to expand. So this polymeric material will expand when the pressure is being increased. So due to that, what will happen to the same kind of a lever and pulley system, screw system is being applied behind this needle. Okay, so due to that, the pressure needle will notify what is the kind of a pressure that is being applied from the bottom. Based upon that, this polymeric material will expand, and based upon the expansion of polymeric material, the pressure needle will oscillate. Okay, so this is what a diaphragm pressure gauge. So this is the content for diaphragm pressure gauge. You get to know. So a thin flexible diaphragm membrane that deflects under applied fluid pressure. So it is applied in the food processing, medical units, medical equipment kind of a thing. So another one is a bellow pressure gauge. So bellow pressure gauge, it is kind of a screw type. So this kind of a material, the pressure is being applied from the bottom. The bell type, the bellow type. Okay, what's happening is it's a shrink and expand. When the pressure is being high, what's happened to it? The bellow will shrink. When the bellows get shrink, what is automatically happening is the needle will get notify what kind of a pressure is being applied. As you see closely this needle system, you get to know how it is actually functions. Okay, so this is what a bellow pressure gauge. So this is the content for the bellow pressure gauge. It is basically applied in air conditioning system, pneumatic systems, vacuum measurement, refrigerations kind of a thing. We will use it. So where are these application of pressure gauges is being applied is, as you see, it is in the boilers to prevent over pressurization, or in hydraulic pressure equipment machineries, or automotive and pneumatic industries, and the packaging food preservation industries, HVAC, hospitals, laboratories. Here we are using pressure gauges. Okay, in the hospitals also you can see pressure gauges with attached with the pipes. Okay, as you see, hydrogen, nitrogen, and oxygen pipes will be in the hospitals. In all the pipeline systems, the pressure gauges will be connected to the each end of the pipe. So, what is the limitation, the advantages of the mechanical gauges and advantages? Mechanical gauges will explained here. So, mechanical gauges have the tendency to maintain period regularly. If you are not going to maintain regularly, there will be some problem. So there is a wear and tear problem is there. So periodic maintenance is required. But the precision is not, the accuracy is not much higher. Okay, high precision is required when we are using. Only digital sensors will give us a high precision, but mechanical gauge doesn't give a high precision accuracy value. And this mechanical gauge will vary or will be deflected due to vibrations or shock loads. Even the pressure gauges get uh, malfunction due to vibration and shock loads. Okay, so and calibration is required frequently. So and the remote monitoring is not possible. Okay, we cannot sit from one end of the industry and monitor the one end of pressure gauges. Okay, we needed to go directly and see the pressure gauges. What is the reading that is being showing? So it is very difficult to monitor remotely. But there are also some advantages of mechanical gauges. So it is a simple and robust design. Okay, a simple and robust design and minimal maintenance is required. The periodic maintenance is there, but even though there is a periodic maintenance, only minimal maintenance is there. Okay, and it also works very long term. Okay, even for 50 years, if you maintain properly, it will work properly, and it doesn't need any electricity. No electricity is required, and it is not and if it is doesn't need any even through it is reliable in remote or hazardous environments. Okay, so if you are going to work in any uh, Antarctica kind of a place, desert place, so electronic items kind of doesn't work there. Okay, due to the environmental conditions, but these pressure gauges, mechanical pressure gauges work properly, work well even though in the harsh conditions, and it is suitable for wide range of pressures. Any kind of a pressure we can apply, That is up to 1000 kilopascal we can use mechanical pressure gauges. When it comes to digital sensor, it is a little bit of tough. Okay, and easy to read with dial pointers. Only the dial pointer is there, so it is visual representation. So we will get to know what is the value approximately. Okay, because we don't know the accurate value, but we will get to know the approximate value, and it is very cost effective and widely available compared with digital sensors or electronic sensors. So there are advantages and limitations of using mechanical gauges, but in many industries they are changing towards electronic pressure gauges, but still local industries, small scale industries are using mechanical gauges. But at the same time, on the harsh conditions, people working in harsh condition or even the bottom of the ocean, people are working. They are still using mechanical pressure gauge. So this is what about the types and classification of mechanical gauges and advantages, disadvantages of the mechanical gauges. So I hope you understand what is some gauge, pressure gauge. So thank you for your patience for fully understanding this concept. So thank you.